So let's go back to your time at Stanford at SOL, because that was a very exciting time for research.
It certainly was. So Philip, Walter, Michael, and I worked together as a team of 4, and it's always hard to describe to an outsider what's happening. People always say, well, who's really doing the work? You know, as if the rest of you are kind of on the coattails of the person who's doing the work. We all did the work, but it varied depending on what we were working on. And I've tried hard to think how to describe this, because people say, what's it like working as part of a team? And I don't know how to describe it. We would talk to each other all the time. Usually there would be 1 or 2 things we were working on. Different people were working on different things. Philip, Walter, and I wrote a book, which we published in 1981. Michael was invited to join that, and he didn't want to, so that took quite a lot of time. That was writing things up, which is slightly different than doing the research.
Well, that was a very influential book, and do you have any idea how many copies it sold?
I don't, actually.
It was a lot, though, I think.
I think
it was used for graduate courses for years.
Right. It's 30 years old, and it's held up pretty well, I have to say. So the biggest excitement happened twice. Okay, so George Dantzig in 1947 invented the simplex method for linear programming. Linear programming, minimization of a linear function subject to linear constraints, which sounds simple, and many people didn't understand how important it was. An extremely important problem. And his algorithm was specially designed for linear programming.
The simplex method.
The simplex method. And it used very heavily the structure of an optimal solution of a linear program. And for years, starting in the 60s, so it was invented in 47, it was a big success in practice from the word go. But in the 60s, people started getting interested in computational complexity, people in computer science, and they wanted to know, if you have an algorithm, what's the worst case time it can take? So how much time can it take for a certain problem size? And the worry was that the simplex method, which follows the edges of a certain feasible region defined by linear constraints, could be very expensive. In 72, a famous example by Victor Klee, and I'm not sure of Minty's first name, the Klee-Minty example showed that the simplex method, in the worst case, could take an exponential number of steps, which is what the complexity people had feared. So the wisdom is only a polynomial time algorithm can be good, can be fast. So it was a funny situation because the simplex method was used by practitioners all over the world, and they thought it was fast, and it was fast. Worst case could be exponential time, and this was unsatisfactory. So for a long time, people kept saying, is there a polynomial time algorithm for linear programming? And many people worked on this and were not able to get a solution. And the Klee-Minty example showed that the exponential bound was achievable. So in 1979, Kachiyan, a 28-year-old Soviet mathematician, published a paper which had a polynomial time linear programming algorithm in it. It was based on early work by Shor, Nemirovsky, and Udine, which was on nonlinear problems, but his was for linear programming. So it was very interesting. It was in the New York Times front page below the fold, so not super important. Soviet mathematician makes breakthrough in linear programming. And it was completely misrepresented. I mean, they said a Soviet mathematician has shown how to prove, that linear programs can be solved in polynomial time, but it basically implied that the Soviets, remember, it was the Cold War, were going to crack all the US codes and break all our cryptography systems and cause havoc and wreck everything. So the phone in our department was ringing off the hook because all these reporters were calling George Dantzig and saying, what do you know about this? Is it true? Is the US open to attack by the Soviets now because of this math? Blah, blah, blah. It was very exciting. And it was a particularly funny experience I had was talking to a reporter for a pretty good publication, and he was saying, well, what does polynomial time mean? And I said, well, you know what a polynomial is? No. So I started saying, well, you have x and then you raise it to a power. And he said, doesn't it just mean it's really, really fast? And I said, no, it doesn't mean it's really, really fast. It means it has this certain form. And he said, thanks. I mean, he didn't want to know. His readers did not want to know what polynomial time. I think his story just said polynomial means fast. Anyway, our group, the four of us, decided to implement Kachiyan's method and try it on some linear programs. What we found was it was much slower than the simplex method. It was polynomial time, but the bound was huge, and it wasn't in any way a competitor to the simplex method. But it was polynomial time, and that's the big theoretical breakthrough. That was 79.